Math 1, 6.6 homework. So, rotational symmetry. So, what fraction of a turn does the wagon wheel below need to turn in order to appear the very same as it does right now? How many degrees would that be? So, it would have to turn one wagon wheel, right? This would have to turn to that one. So, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So, it would have to turn an eighth for that to work. Well, how many degrees would that be? Well, a full circle is 360. So if we divide 360 by 8, that's going to get us our answer, okay? So 8 goes into 36. How many times? 4, which is 32. Subtract that. Bring down the 0, 5. So it would be a 45-degree turn. Okay, number 2, for the propeller. There's 1, 2, 3, 4, 5, so it would be 1/5. Would be the fraction. How many degrees? Well, 360 divided by 5, right? So that would go in 7 times, 35, 7 times, subtract, and then that would go in twice. So it would be a 72-degree rotation. Number 3, what fraction for this model of the Ferris wheel? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 1/18. How many degrees? Well, 360 divided by 18. That would go in twice, right? 36, be 0, so it would be a 20-degree rotation there. Each one of those would represent 20 degrees. All right. Now it says draw the lines of symmetry for each regular polygon. Fill in the table. So, line of symmetry for a triangle. Because they're regular meaning all their sides are the same, we'd have 3. For a square, a vertical one, a horizontal, well, not that those are drawn very well. And 2 diagonal ones. I think that's it, so that would be 4. For a 5-sided pentagon right here, right there, 3, 4, and 5. For a hexagon, right there, basically every side, and then also every diagonal. So that would be 6, right? For 7, 1, 2, 3, 4, 5. Oh. Let's try that again. 1, 2, 3, 4, 5, 6, 7. So we see a pattern here. So 1, 2, each vertex, 3, 4, and then each middle point, 5, 6, 7, and 8. So an n-sided figure would have n lines of symmetry. Okay, so what do we see in the pattern there? Well, we see all these odd ones. Okay, they have one that goes from a vertex to the side opposite, and they have that many vertices as sides, so that's why that works for odds. For evens, like these 3, they go from a diagonal, plus they go in between the sides. But the way it ends up is that you'll have the same number of lines of symmetry as you have in number of sides, if it's a regular polygon. If it's not a regular polygon, then it's not going to work. Okay? Let's see diagonals now. So you draw all the diagonals. So in a triangle, there's 0. Square has 2, vertex to vertex, but not the ones that are part of the sides. Okay, pentagon we have 1, 2, 3, 4, 5. Hexagon we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I believe that's it. Notice that each vertex has 3 diagonals here. But then, you cut that in half, and because some are done, we'd get 9. Okay, does that work here? We have 2 sides for each, which would give us 10. Cut that in half, and 5. We have 1 for each. Cut that in half. Okay. So there's actually a pattern here, isn't there? Okay, for 3 we have 0. So we take the number of sides, we subtract by 3, right? Because 6 sides we had 3. 5 sides we have 2. 4 sides we had 1. 3 sides we had 0. So subtract that by 3. Okay. That gives us how many for each vertex. So times the number of vertexes, which is the same as sides. So instead of 5, I should go n here. Okay. Then we cut those in half. And that's a formula to do that. So let's see if it works. So 7 times 7 minus 3 over 2. 7 minus 3 is 4. 7 times 4 is 28. Divide by 2. We should have 14. Let's try it. So 4 there. 4 there. 4 there. 4 there. So it looks like we have 4. Yep, 4 for each vertex. So, yep, 4 times 7 divided by 2 would give us 14. Okay, so for the 8, we have 5 for each side, right? Because it would be 8 minus 3 would give us 5, times the number of vertices, which is 8. That would be 40, divided by 2 would be 20. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. When they get that big, it's hard to tell, isn't it? So for n, would be that formula right there. So there is a pattern to that one. All right. Okay, it says find the angle of rotation that will carry the 12-sided polygon below onto itself. We'll think back to what we did up here, right? However many slices there were, we divided that into 360. Well, okay, basically those were all the vertices, right? Just across from each other. Like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So same as number of sides, right? So if we take the number of sides, divide it by 360, okay, in our case 360 divided by 12, we would get, that goes in 3 times, so 30. So it would be 30 degrees. Okay, now, that's just one. If we kept going, that would be every 30 degrees. So we could get the multiples of that to make it work. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. Okay? Said, what about the angle of rotation of a 20-sided figure? And how many lines of symmetry will it have? Okay? Well, lines of symmetry, we remember we did those, and we had the same. So we'd have 20 lines of symmetry. Okay? Half of those would be diagonals as well, and they would be reflector. Then we'd go 360 into 20, so 20 goes into 360 once. Subtract that, that would be 1 and 6. 20 goes into 160 8 times. So we'd have an 18-degree rotation, which, you know, we could keep times in it by 1, by 2, by 3 until we got up to 360. Now this had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different angles. Okay, so this we'd go up to probably 20 different angles until we got to 360. Okay. So number 8, how many lines of symmetry will it have for 15-sided? It would have 15. And that many lines of reflection as well. Okay, the angle of rotation, we go 360 divided by 15. Goes into it twice. be 6, bring that down, go into that 4, so it would be 24 degrees for the angle of rotation. Okay, how many sides does a regular polygon have that has an angle of rotation of 18? Well, we already figured that out, right? It was 20. If we weren't sure, we could go 18 would equal 360 over n. So basically, go like this and cross multiply. 360 equals 18n, divide by 18. But we already know that it's going to have 20 sides. Okay, last question. How many sides does a regular polygon have that has an angle of rotation equal to 20? Okay. How many lines of symmetry would it have? Well, let's find. So if I go like this, 360 over n equals 20. Okay, times by n. You get 360 equals 20n, divide by 20. And we know 360 divided by 20 gives us 18, so we'd have 18 sides. So just the opposite, right? So if it had 18 sides, it would have 18 lines of symmetry. Okay, there we go for 6.6.